Clay swelling caused by the use of potassium chloride substitutes. We are often asked about the effectiveness of potassium chloride substitutes in the prevention of clay swelling. Sandstone sedimentary basins are almost exclusively marine depositions. This means that the oil-bearing sandstone reservoirs are typically compatible with seawater. If a reservoir's mineralogy is sensitive to low salinity brine, then adding a potassium chloride substitute will provide no additional value. In order to confirm this, we will demonstrate the swelling properties of one of the most sensitive clays found in sandstone reservoirs, sodium montmorillonite, or sodium bentonite clay. Sodium bentonite clay can absorb many times its weight in water and swell up to 10 times its volume. We will begin by putting 10 grams of sodium bentonite clay into 4 graduated cylinders. We see that this occupies roughly 12 milliliters of volume. We will then add roughly 100 milliliters of fresh water, seawater treated with a potassium chloride substitute, untreated seawater, and lastly seawater treated with PIC safe seawater product. Upon addition of the fluids, we will agitate the clay so that it is fully suspended within the liquid. We see now the clay suspended in the fluids, with some settling already occurring in some of the graduated cylinders. We will now let the graduated cylinders rest for several hours. This will allow the bentonite clay to settle, so that we may observe any swelling that has taken place. Several hours have now gone by, and we can observe the swelling that has taken place within each fluid. We see that the fresh water was readily absorbed by the clay and swelled to 8.3 times the original clay's volume, but would have swelled even more so if a larger volume of liquid had been added. In the case of seawater treated with potassium chloride substitute, the amount of swelling is significantly reduced in comparison to the fresh water, but the clay still swelled to 3.7 times its original volume. Now looking at just seawater, we see that the potassium chloride substitute actually did less to prevent clay swelling than seawater simply by itself, with seawater swelling the bentonite clay to just 3.3 times its original volume. PIC safe seawater product contains clay stabilizing additives, but even with these stabilizers, we see that the seawater treated with safe seawater swelled more or less the same as seawater on its own. We are often asked about supplementing seawater with potassium chloride substitutes for added protection against clay swelling. This demonstration showed that clay swelling and clay stabilization is not the biggest issue we face with the introduction of seawater to reservoir mineralogy. Seawater does just as good a job as clay stabilizers and an even better job than 2% potassium chloride equivalent solution. Seawater comes with many risks. High sulfate content can easily lead to norm scale, and high microbial content can lead to induced corrosion and corrosion products. There are many risks of using seawater, but clay swelling is not one of them. Don't treat what isn't a problem. This demonstration has been presented to you by PIC Chemicals. Don't leave oil behind. Thank you.